So this is actually the third video, but it's actually the second video on this homework assignment. Let's jump to number 4. I'm not doing 1 or 5 or 9 because we already did those. So let's jump to number 4. And step 1 is to rewrite in slope-intercept form. You want y by itself. So you have to add x to both sides to start getting y by itself. Now remember, you want y equals mx plus b. Let me write this down on the side. Y equals mx plus b. This is what we want, so we're changing it to look like this. You want to get y by itself. So we added x to both sides, and x and a negative x cancel out, so it's 0. So I have a 2y left over. I still have the inequality that's less than. And over here, I can't do negative 4 plus x. I can't do that, so I'm just going to rewrite it. Of course, you want the x term first, so let me put the plus x first, the positive x first, and then let me put the minus 4 at the very end. So what number's in front of x? 1. So let's put the invisible 1, let's write it out there. And now let me actually get y by itself by dividing everything by 2. And there's my final slope-intercept form inequality. So the 2's cancel. I end up with y all by itself. The inequality did not flip. Notice that it stayed exactly the same. Why? Because I did not divide by a negative. You only flip it when you divide or multiply by a negative. So I'm going to rewrite everything else. I have the 1/2, the x, and I also have a minus 2 at the very end. And now it's in slope-intercept form because you could clearly see your slope and you could clearly see your y-intercept. The slope is 1/2, the y-intercept is negative 2. So how do we graph this thing? You go to negative 2, your y-intercept, and then you rise and run according to your slope. So it obviously crosses the y-axis at negative 2. Everybody should put a dot right there. And from that point, rise 1 and run 2. So if you're at this dot and you go rise 1 and run 2, you end up right here. So let's put a dot right there. And you could continue to rise 1 and run 2 and put a dot right there. And you could continue to rise 1 and run 2 and put a dot right there. As a matter of fact, on these inequalities, you want to go all the way from one side of the graph to the other side. So I'm going to use the same pattern of rise 1 and run 2, but I'm going to go backwards, this way 2 and down 1, this way 2 and down 1. That way I could really extend it from one side of the graph all the way to the other. So that's the old stuff that we already knew how to do. The new part kicks in right here where you say, is this going to be a solid line or is it going to be a dotted line? What do you guys say? Solid or dotted? Dotted. Why is it dotted? Because there's no solid line underneath the inequality. So because there's no solid line, it's going to be dotted. So let's put a bunch of dots right between the dots. There's my dotted line. Put some arrows on it. Now remember, an inequality has an area of answers. The answers are either going to be up here on this side or maybe down here on this side, right? So what you need to do is test a point. So you could pick any point you want. Like, let me show you. I could, if I really wanted to, I could pick like the coordinate, this coordinate right here. That's the coordinate 2, 1. X is 2, y is 1. Imagine if I were to plug in a 2 for x right here and a 1 for y over here. Well, that would say 1 is less than 1/2 times 2 minus 2. So if I did the math, the 2's would cancel, and I'd end up with 1 is less than 1 minus 2, which means I'd have 1 is less than negative 1. And would that be a true statement or a false statement? 1 is less than negative 1. That's false, so it doesn't work. So what do we know about this point that it doesn't work? So where are your answers at? This is not your answer, it doesn't work. They're on the other side, right? They're on the other side. So if this one doesn't work, your answers are on the other side. So, I mean, you could say, okay, this doesn't work. That means that my answers are on the other side. So this is why we shade in this side. Make sense? Okay. Okay, so I'm going to jump to number 6 because number 5 is explained on the previous video. If you need that one, check out the other video. Number 6, going quickly through the steps so I could show you how quick this is. Divide by 3 to get rid of the multiplication of 3 in front of the y. You're dividing everything by 3. You're going to have y is greater than 2/3 x minus 1. And that is already slope-intercept form. The m is clearly 2/3. The b is clearly -1. So if you know those two things, the m and the b, you know how to graph it. It crosses at -1. So let's put a dot at -1. From that point, I go up 2 over 1, 2, 3, and I put a dot right there. Again, I went up 2 over 3. Now, if I want to go backwards to extend the line this way, I could go over 3 this way and down 2, over 3 this way and down 2. And that will help me extend the line as long as, or as far as I need to extend it. Anyway, the next question is this a solid line or a dotted line? It's obviously dotted because the only way it's a solid line is if you have a solid line underneath your inequality. So this guy is definitely dotted. So let me put some dots or a dashed line. And of course, you still need some arrows on it. And now you also need a shade. So I'm going to test any point I want. I'm going to test the point 0, 0. Now, if 0, 0 works, then I shade in that side. If it doesn't work, I shade in the other side. So when I plug in 0 for y, it's going to say 3 times 0 is greater than 2 times 0. If I plug in 0 for x, a minus 3 at the very end. So when I plug in 0, 0, I'm plugging it into the original, or I could plug it into the second one, to the modified one. Right? I mean, if you want to plug it into this guy, y is greater than 2/3 times 0 minus 1. You could do that as well. Let me change this y to a parenthesis to plug in 0. So it doesn't matter if you use the new modified or the original. Okay, so here's the new modified. I plugged in 0 here and 0 there. Or I could go with the original and plug in a 0 for x and a 0 for y. There it is. Either way, it's going to give you a true or false statement of the point 0, 0. So down here, I have 3 times 0, which is 0, greater than 2 times 0, which is 0, and then minus 3. And again, 0 is greater than -3. That's absolutely right. So I know that that's a true statement. If you went with the other option, 0 is greater than -1, that's also a true statement. So the bottom line is 0, 0 is an answer. So this point does work. That means that all of these points work over here. Since it does work, I'm going to shade in that side. So since 0, 0 did work, all my answers are up here. I shade in everything up here. If it doesn't work, then you shade in the other side. So I'd have to shade everything down here. So it did work. So I know that every single coordinate up here on this side of the red line will work. If you don't believe me, you could plug in like 1, 2. If you plug in 1, 2, 1 right here, 2 right there, it's going to work. If you plug in any coordinate down here, it will not work. Okay, let's move on to other questions that we didn't explain on the other video. Number 7, let's get y by itself. Plus 5, plus 5. You're going to have y is less than or equal to 1x minus 4. I'm going to put the invisible 1 in front of the x. Not only that, I want to make it a fraction, 1 over 1. That way I could see that my slope is 1 over 1 and my b value is -4. So it does cross at -4. So at the origin, crosses at -1, 2, 3, 4. Right here it crosses. I'm going to put a dot at -4. Now from that point, I'm going to rise 1 and run 1 and put a dot right here. And then right here and right here. Again, you're rising 1, running 1, rise 1, run 1, and so on till you get from one side to the other. And then you also go backwards, go in the opposite direction using the same pattern. Now, is this going to be a solid line or a dotted line? It's definitely solid. Solid? Whew. It's been a long day. Sólido. Whatever. Solid line. I also need to shade, so I'm going to test the point 0, 0. And is it going to work? If I put a 0 right here for y and a 0 for x, it'll actually say 0 is less than or equal to -4. What do you guys say about that? False. So the 0, 0 didn't work. So if the 0, 0 didn't work, none of these points are going to work. So where are my answers at? On the other side, on the bottom. So shade in the bottom. Let's move on to number 8. And we're going to stop right there because on the other video I explained 9. So let's just do 8 and we'll be done. Let's get rid of that 6. We're going to subtract 6, subtract 6. You're going to have y is greater than 2/3 x minus 1. So that one crosses the y-axis. The b value is -1 and the m value is 2/3. So it crosses at -1, and from that point, I'm going to rise 2, run 1, 2, 3, and put a dot there. And then I want to go with the reverse pattern. I want to go from here, 3 this way and down 2, 3 this way and down 2, so I could extend my line from one side of the graph to the other. Now, is this going to be a solid line or a dotted line? Sarah, what do you think? Solid or dotted?
It's going to be dotted line.
Dotted. Why is that, Sarah? Why is it dotted instead of solid?
Because it doesn't have the line underneath the symbol.
That's right. It does not have a line underneath the symbol, so it's not a solid line. It's a dotted line. So let's actually do that dotted line. Put some dots right there. Put an arrow at the end. Another arrow down here. Now let's test the point like the point 0, 0. If I plug in 0 for x and 0 for y, okay, remember this is a coordinate 0, 0, 0 for x, 0 for y, it's going to say 0 is greater than 2/3 times 0 minus 1. So obviously the 2/3 times 0 disappears. So you really have 0 is greater than -1. What do you guys say about that? Is 0 greater than -1? Yes, it is. So this point does work. So all of the points right there work. So I shade in that side. None of the points down here work. All of the points up here work. Okay. So we do have, this is the conclusion of the third video. We have every single question explained on this worksheet. Hopefully you guys understand everything so far. I'm done.